So today we'll be talking about simplifying radicals. So what are radicals?
So radicals are a type of equation and where we have to find the cube of the root of a number. So we might have to find the square root of 9, the cube root of 27. So and the root can be any type of number. So the square, cube, fourth root, anything like that.
So here's an actual radical. So here's the index, radical symbol, the radicand, and the actual sum. So how do they work?
And so as we said in the last equation, this x right here would be the index number. And so this shows whether we're going to find the square root or the cube root or any type of root like that. And so so here I'm going to do this number. So here this shows that the square root of 9 is equal to 3. And so you may be like, how do we know this? Where's the proof and how does this work? And so one way that we found that it was easier to understand is that this is the amount of times you would have to multiply this number by itself in order to get this. And it might seem a little confusing, but once I show you right here, it's going to be simple. So there's this number right here would be 2, which is square root, and then 3 right here. So you have to multiply 3 by itself 2 times in order to get 9. And so also 3 squared is equal to 9. And that's one way to prove it. And so one way to know all the time is that the xth root of n equals y. And if this right here is true, then that also means that the xth root of y equals n. So as we said, here 2 would be x, 3 would be n, and y would be n, and then y would be 9, and the square root of 3 is equal to 9, and the square root, the 3 squared is equal to 9, and the square root of 9 is equal to 3. And so here's another example. We're using a cube root, and as you said earlier, this is the amount of times you would need to multiply this number by itself. And so 2 multiplied itself 3 times is equal to 8, and 2 cubed is equal to 8, as you said. This also correlates with this, what we said. And here we have one that is a bit extreme, and you may not find this in this unit, but it's still good to know about it. And so here we have the number 4, and so here's number 4 also. And the fourth root of 256 is equal to 4, which means that 4 times itself 4 times is equal to 256, which would mean that 4 to the 4th power is 256, and this is all true. And so now we have some more examples. Here, I'm going to go through these a little quickly. And so the square root of 81 is 9, and so to know this, we must know that 9 times 9 is equal to 81, which means that 9 squared is 81. And here, one thing that's also needed to know is that if you do not put a number here, then it is defaulted that you would know that the number is 2. So you can either put 2 or no number there. It does not matter which one, you'll still get it right. And so here, the square root of 64 is equal to 8. And so we know 8 times 8 is equal to 64. And so 8 squared is equal to 64.
So now on to the negative. Let's just go on to the negatives now. Here's actually an example of, we're going to start off with negative. So let's say for now you're probably confused on like, oh, what about if there's a negative number in the radicand? So here we're going to start off with 49. So with 49, what we're going to do, we're going to split the 49 into the negative symbol. So because we know any number times -1 is a negative number, we're going to split this into 49 times -1. And because we said earlier, you can split these into 2 radicands, we'll have -49 times 49 times -1. And because we know the actual square root of 49 is 7, we can bring that down and change that to 7. And we're going to continue having the negative I as a radicand. And with radicands, we know that the square root of -1 is an actual I, which represents imaginary numbers. And with that, we bring this down to 7I. Imaginary number, I represents imaginary numbers because they wanted an actual way to represent negative numbers. So yeah. And here's more extreme root. So here's more of like here's a different example. -42. So what we know. Actually, go ahead, continue.
Okay, and so we have -52, and so here we went and split it up as 4 and -13, and so if we have this the square root of quote 4 times -13 end quote, that is the same as square root of 4 times square root of 13, and so we know that the square root of 4 is equal to 2, and so we would just bring down the 13, and since there's no factors of 13 other than 1 and 13, we know that there's no more way to simplify it. But what we need to know that we have to bring the I over here right next to the 2 outside of the radicand to finish the equation, and so we have 2I square root of 13 would be the most simplified answer that we can use.
So these are simplifying radicals, and have a nice day.